Okay, now let's start coding LFM2, this foundational large language model. I'm gonna start by just writing some configs and then rest of the code. And the thing is, most of the code is going to be based on the work of this guy, the Kai Gomez. However, I'm gonna change some parts of the code because I feel like some of the functions like rotary positional encoding and I don't know RMS norm, so on and so forth, can be implemented better. But yeah, so this is going to be somehow the base of this work. So yeah, let's start by just some for the config. Just let's start by some imports. We can import torch. We can import, and I'm gonna use this autocomplete, by the way, which makes it technically faster. We're gonna import neural net from torch.nn, functional from torch.nn.functional, different typings, and data class, because we're gonna type the in fact LFM2 config within the data class, and so on and so forth. But we also need to do a kind of before this we need to add technically a logger, which we use this try, and we're gonna use logger for it. Import logger from logger, and if it is true, just import it. If not, just make an exception and raise an error. So I'm gonna accept this, and yeah, and then we're gonna use a data class in order to in fact make the oops, make the, if I can make it, yeah, make the LFM2 config. So class is going to be LFM2 config. So if you remember, we had different blocks: convolutional block, we had rotary positional encoding, we had transformer blocks, so on and so forth, and we're gonna import all of those in fact all those configs right here. So what we have vocab size, we have hidden size, and under vocab size, as you know, it is technically the size of the vocabulary. The hidden size is the hidden dimension size. We have intermediate size. What is intermediate size? It is feed forward intermediate dimension. We have convolutional, number of convolutional blocks, which is technically number of convolutional blocks within our architecture. Then we have number of attention blocks, we have number of attention heads and number of key value heads, which are respectively number of group query attention blocks, and the second one is number of attention heads and also number of key value heads for group query attention. Then for the in fact conv kernel size, technically it is the kernel size for the convolutions. The max position embedding, what is the max position embedding? It is the maximum sequence length of the that can be accepted within this rotary positional encoding or arrow positional encoding. Also we have RMS norm epsilon, which is technically normalization parameter for the RMS norm, and I'm gonna accept these. And we have also tie word embedding, which I can, yeah, as we have it here, we have tie word embedding, which is whether to tie input or output of the embeddings. Then we have rope theta, which is the rope base frequency. And also, if you want to know more about rotary positional encoding, you can have a look at my video for Mistral. I'm gonna explain it thoroughly that how rotary positional encoding works. So if you don't know about rotary positional encoding, pause the video and go back there and have a look at it. Make sure that you understand what is rotary positional encoding and how it works. Then we have where is it? Attention dropout, which is the technically dropout rate for attention mechanism. Then we have hidden dropout, which is dropout rate for the hidden layers. We have initializer range, which is a standard deviation for weight initialization. We have use cache, whether to use the key value caching or not. We have path token ID, beginning of sentence, end of sentence IDs, so on and so forth. We also have use return dict, which is whether to return output as a dictionary. We have output attentions, whether to output attention weights by default or not. And also we have output hidden states, which is whether to output hidden states by default or not, which I'm gonna accept them all. And the thing is, they all have predefined values, which I'm gonna technically populate them with those numbers. So for the vocab size, we have 32,768, and then for the in fact hidden size, we have 10,024. Then for the intermediate hidden size, it is technically double of that size, a bit more than double, 2,816. Then for the in fact number of conv blocks, we have 10 of them. So for the attention blocks, we have 6 of them, if you remember, within the code and in the diagrams I showed them to you. The attention head, we have 16 of them. The key value heads, 4 of them. And then for the conv kernel size, it is equal to 3. For the max position embedding, the sequence length, technically it is 32,000 again. For the RMS norm epsilon, it is this number from in fact 10 to the power of -6. Then tie word embedding, it is so true. Usually the rotary positional embedding theta value is 10,000 as in the base paper. And again, if you don't know about it, just go back to my video and have a look at it. Then we have attention dropout and hidden dropout. We keep them for simplicity 0, and feel free again to change them to whatever you like. Find whatever best works for you. We have initializer range of 0.02. Use cache. Yeah, do use cache. We can use the cache, and also for the path token ID, beginning of sentence, end of sentence, we respectfully choose 0, 1, 2. And for other, to use return dict, whether return output attention and whether return the output hidden state, we use true, false, false for the rest of them, and we don't. And yeah, we can add this part as well. So the thing is, when we want to train this model, so based on the paper, and if you look at their in fact GitHub and Hugging Face repo for Liquid, you can see that they have different configurations with different LLMs with different sizes. So we have 350 million one, we have 700 million one, and we have 1.2 billion one, which each of them they have different hidden sizes, intermediate sizes, number of attention heads and key value heads as well, so which I'm gonna accept this as well. So as you can see, for the 350 million parameter, we have 768 hidden size, which is pretty much the same as bird, and the rest of them, as you can see, it doesn't change that much. For 700 million and 1.2 billion we have 1000 and 1,500 hidden size, and the rest of them, as you can see, so this one is very much like kind of Mistral, which is kind of a really large language model. So yes, this one was particularly about the configs and how you can define those configs and so on and so forth. And next I'm gonna jump into the RMS norm.